हेलो केयूर सर, गुड मॉर्निंग, गुड इवनिंग सर।
हाँ बोलिए सर।
आपका कोई फ्रेंड है सर, अमोल करके ना?
अनमोल अनमोल।
अनमोल ना?
हाँ
ज्वाइन करना चाहते हैं वो शायद इंस्टीट्यूट।
हाँ, वो शायद आपसे डेमो लेक्चर वगैरह के लिए बोला होगा उसने।
हम्म। तो ठीक है, देख लीजिएगा जैसे आप।
तो आप दे दीजिए ना उसको लिंक। आपसे बात नहीं हुई क्या उससे?
मेरी बात हुई है, वो अभी बंदा थोड़ा सा बाहर है।
अच्छा अच्छा।
थोड़ा तो ये सब उन्होंने बोला कि मैं थोड़ा सा गांव साइड में हूँ, इसलिए थोड़ा दिक्कत है, मैं देखता
अच्छा
हूँ।
अच्छा ठीक है, तो फिर वो जब भी आए तो आप दे दीजिएगा उसको लिंक को, है ना?
हाँ, मैं बोला हूँ कि आप एक बार देख लो सर।
ओके ओके।
ठीक है सर, ओके ओके सर, बाय सर।
Very good evening, guys. How are you doing?
गुड इवनिंग सर।
How was the New Year? How is the New Year treating you guys?
वो थोड़े दिन में पता चलेगा सर।
मेरे थोड़ा हल्का सा ठंडा हो गया, but I don't know, I'm got a cold little bit. Anyways, maybe because of yeah, और weather भी यहाँ पे मुंबई में एकदम अजीब हो रहा है. Anyways, केवल आपने मेरे को जो जॉकी पंप पूरा सा पूछा ना, ठीक है?
हाँ सर।
Jockey pump is a pump which is additional to your system, ठीक है? मेन सिस्टम के साथ में अभी जिधर भी आप जॉकी पंप सर्च करते हो नेट पे, वो जो फायर पंप के साथ में लगा के दे रहे हैं ना,
राइट राइट राइट।
एक मिनट ना, जस्ट होल्ड ऑन, गिव मी अ सेकंड. All right, sorry about that. I just received the call. अच्छा, I was just saying that whatever you're seeing, जो भी आप देख रहे हो ना, वहाँ पे जो फायर पंप के अंदर, you understood why that jockey pump is given in that fire pump system?
That is to maintain the pressure in the sprinkler system.
But the question is, why will the pressure not maintain? Because that is for a system which is connected to your groundwater system. समझा? तो मतलब उसके अंदर एक constant pressure से एक maintain करके रखा है, and it is not like independent system like our on the ship. तो वहाँ पे वो fire pump के system में नहीं होता है. I checked in the sprinkler system also. There is nothing like what do you call separate jockey pump करके ऐसा नहीं है to maintain that pressure system. I was seeing in the sprinkler as well as hypermist. Hypermist
Yes,
में
sir.
hypermist का pump है, separate pump है वो, ठीक है, that is a separate multi-stage pump and everything.
वो तो खुद ही मेन पंप ही है बेसिकली,
Main
उसमें
pump
कोई.
है, there is no additional
हाँ,
pump in that. There is no
राइट राइट.
in that. Similar with sprinkler also, you just have got one sprinkler pump and then one separate backup from the seawater system. Okay, there is no additional what do you call pump to maintain the pressures. So the only other place where I could find reference was jockey pumps were used as feed pumps, where you had a constant supply was the running of the oil was there. अंशुल याद है हमने डिस्कस किया था ये क्वेश्चन कि हाउ द ऑयल इज नॉट बीइंग व्हाट यू कॉल अलाउड टू फ्रोज, so constantly we had to keep the supply going in the system. So that small pump which was there was a jockey pump. Okay, that is the name of the type of pump. ये किसने पूछा, कहाँ पूछा, अभी व्हाट्सएप पे क्वेश्चन लग रहा है मेरे को.
ये रिसेंटली पूछा था सर, मैं किसने पूछा मैं देख के बताता हूँ आपको.
First I thought you said I was thinking maybe जेनी pump. जेनी pump तो आपको पता है क्या है ना?
नहीं नहीं, जॉकी पंप पे पूछा था सर.
नहीं, but you know what is जेनी pump?
कौन सा पंप सर? जेनी.
Janey, जेनी, JANNEY. आजकल जो आपके जो स्टीयरिंग सिस्टम्स के अंदर पंप होते हैं ना, दे आर कॉल्ड एज जेनी पंप्स. बेसिकली दे आर हैविंग द स्ट्रोक कंट्रोल्ड बाय योर व्हाट यू कॉल टॉर्क मोटर. तो वो डायरेक्ट जो स्ट्रोक कंट्रोल होता है विदाउट हैविंग अ सेपरेट कंट्रोल लीवर एंड एवरीथिंग, नो, इंटरनली कंट्रोल. तो वैसे वो टाइप का पंप को जेनी पंप बोलते हैं, JANNEY.
ओके ओके.
ठीक है. अच्छा, अदर थिंग
ये गुलाटी सर का क्वेश्चन है.
गुलाटी सर क्वेश्चन. But I haven't come across this jockey pump before. Recently पूछा होगा मेरे को लग रहा है.
हाँ, अभी आज या कल में ही पूछा था. मतलब 29th को पूछा था या आज पूछा था.
Okay. Just give me a second. हाँ, 29 को पूछा है. और ETO क्लास में किसी को पूछा था जॉकी पंप फेलियर स्टार्ट ओनली फॉर जॉकी पंप. Just give me a second. वो प्रैमो के हिसाब से ना, somebody had asked why Pramo system alarms and trips hydraulic pressure alarm दो, तो किसी ने आंसर दिया था जॉकी पंप फेलियर. तो ये कंफर्म हो गया, जॉकी पंप का जॉकी पंप इज रिलेटेड टू दैट अपना जो कांस्टेंट सप्लाई प्रेशर फॉर योर Pramo पावर पैक. तो
ये कहाँ से आपको मिला सर? ये कोई ETO को पूछा था क्या, ये वाला क्वेश्चन जो आप रीड कर रहे हैं?
ETO के ग्रुप में किसी को पूछा था तो किसी ने जवाब दिया था. एंड उसके बाद एक्चुअली आई केम अक्रॉस टुडे ओनली in the evening when I was searching, no, I found some reference कि jockey pumps are there in Pramo system to keep it continuous supply on the between the Pramo power pack to the line, right up to the Pramo systems to keep the circulation on. Okay, so that pump जो था छोटा pump है, because I have not worked on Pramo, so I had asked somebody, so he told me a small type of pump is there. So exact nomenclature I did not know. So yeah, because the idea वही है ना, जैसे in the अभी जो हमने जो पढ़ रहे हो ऑनलाइन, ठीक है, जो जॉकी से जिधर भी आप सर्च करते हो, इट इज फॉर द फायर फाइटिंग सिस्टम. तो आइडिया मेन पंप के साथ में पैरेलल लाइन में एक दूसरा पंप कनेक्टेड है, which is a very low what you call head pump. It is just giving maintaining the pressure. ठीक है, it is not low, sorry, throughput pump. Head तो उतना ही मेंटेन करेगा, but throughput कम है उसका. ठीक है, बहुत छोटा थ्रूपुट है. एंड इट इज जस्ट जैसे वो अगर आपका मेन लाइन प्रेशर कम हो गया तो अदरवाइज व्हाट विल हैपन इज दैट ऑटोमेटिक स्टार्टिंग ऑफ योर बिकॉज़ इट विल सेंस अ लो प्रेशर. ठीक है, तो प्रिवेंट दैट इज देयर. तो आइडिया क्या है, इट इज इन कंजंक्शन विद योर मेन पंप, यू हैव गॉट योर दिस पंप. ठीक है, दैट इज आइडिया. सो दैट इज द सेम आइडिया ओवर देयर. ETO ग्रुप में भी किसी को पूछा था कभी लॉन्ग बैक reasons for hydraulic low pressure alarm. So jockey pump failure. I was actually trying to search my Pramo manuals, but वो मेरे को अभी time नहीं मिला because my computer had just shut down, so I just restarted it. I was just trying to search in the मेरे को Pramo manual में उसका reference मिलेगा ना, so I will confirm it also. बट जो मेरे को ऑनलाइन मिला उसमें लिखा था कि इन द प्राइमो सिस्टम टू मेंटेन द कांस्टेंट सप्लाई ओवर द दिस थिंग, क्या बोलता है, इन द व्हाट यू कॉल, फ्रॉम द पावर पैक राइट अप टिल द पंप. अच्छा, एक और क्वेश्चन आपको पूछता हूँ. हाउ एग्जैक्टली डज द हाइपरवेस्ट सिस्टम रिमूव फाइट द फायर? हाउ डज इट फाइट? Just came across this one question also. Somebody was asking me today, one another student, not अपने class वाला नहीं, somebody who I was interacting with, he said that उनको ये पूछा था question. I think it was by I think कौन था surveyor.
So basically cooling and starvation.
How?
So hypermist में what it does is it uh, the high pressure water, when it passes through the nozzles, it gets converted into very fine droplets of water, mist like droplets of water, and this basically provides the cooling effect as well as starvation because it replaces air from the space.
Okay, so you are telling if I want to talk about mechanisms, how, because एक कैसा है ना, अपने को थोड़ा सा आंसर थोड़ा बड़ा करके बताना पड़ता है, ठीक है?
Mhm.
So how would you, if somebody asks you what is the mechanism, how it fights the fire?
Okay, so process he wants to know.
Yes.
Okay, how it operates and all that.
Anything, how it fights the fire. मतलब, if I am releasing hypermist into a chamber where you have got a fire, how does it actually fight the fire? आपने जो बोला वो करेक्ट है, बट वही मैं बोल रहा हूँ, if I want to break it down into mechanisms of how it fights the fire. See, पहला mechanism तो heat extraction है, ठीक है?
Yes.
ठीक है, हीट एक्सट्रैक्शन है कि अगर वो इवेपोरेशन से हीट अवे निकाल लेता है तो आपका जो फ्लेम है, तो फ्लेम में से 30 to 60% निकाल लेगा, तो अबाउट दैट मच योर बिलो द थ्रेशोल्ड ऑफ द बर्निंग कंडीशन आ जाएगा, तो इट विल नॉट अलाउ द फ्लेम टू प्रोपगेट. दैट इज वन मैकेनिज्म. Second mechanism, you just now said that as it is in a very fine droplets, it will fill the basically the area with entire droplets. It will basically deluge the entire system with the fine droplets, and it will basically displace the oxygen. Okay, that is the second mechanism. Then there is also a third mechanism. Basically, apart from the actual heat absorption from the uh, actual source of the fire, like the seed of the fire, it also uses, it also displaces the absorbs the radiant heat. Okay, so as the small water droplets are suspended in the air, it reduces the radiant heat transfer between the flame and the nearby objects. Okay, and therefore absorbing the heat and basically not allowing the secondary objects to catch fire on. तो ये अगर ऐसा बताओगे ना, wait, I have it somewhere. Just let me just share my screen. मेरे पास है किधर लिखा हुआ ये सब. Okay, I just share the screen now. उसके बाद share किया था. Because he asked me कि can you tell me the mechanism by which it fights the fire? I said very simple है, तो clear नहीं पूरा था. Mechanism पूछ रहा है और वो he's not satisfied with your whether just a simple answer के जैसा आपने बताया ना कि fine droplets है, ये है, तो we had to recall.
So that is the only issue, मतलब with me at least, because इस टाइप के क्वेश्चंस में like I cannot expand very much on the spot. मैं ये सब बाद में सोच सकता हूँ मैं, but उस टाइम पे does not come naturally. मतलब I try to pinpoint जितना प्रिसाइज हो सकता है उतना करने की कोशिश करता हूँ, बट एक्सपांड करना थोड़ा मुश्किल हो जाता है.
हाँ, तो मतलब वो थोड़ा सा उसको वही खींच तान के आपको जवाब देना, मतलब बेसिकली you have to get your explanation a little bit more this thing. This is right from some manual or something I had taken out some time back. The result of the division of water into very fine droplets increases the total surface area able to absorb to maximize the evaporation rate of the water. Process of evaporation takes away the heat from the flame on fire plume when I arrive at the source of the fire. is not necessarily extract all the heat being generated from the combustion reaction to stop it. By extracting 30 to 60%, it is enough to drop it below the threshold burning condition. Second mechanism is it extinguishes the fire, oxygen displacement, starvation of this thing, displacement of the basically smothering only. ठीक है, तो अगर वो oxygen निकल जाएगा तो वो smother कर देगा. The expanding water droplet displaces the normal air. Means basically expanding water droplet means vapor is basically saying when it is forming the steam. Okay, as soon as it vaporizes, displaces the normal air and reduces the amount of oxygen within the fire. The water vapor can be confined within the fire. ये सब ठीक है. And ultimately the surface fuel surface will be reduced and the fire will be extinguished. Third is radiant heat attenuation. Small droplets suspended in air. ये वही है देखो. Basically preventing nearby objects or by scattering and absorbing the heat. तो radiant heat को भी करता है, actual heat को भी करता है और oxygen displacement को भी कर देता है. That is idea. So these three mechanisms by which you fight the fire. Of just today only somebody was today or yesterday he was asking me. Yesterday he asked me this question. Okay. Any other questions?
सर एक ये कॉफर डैम से रिलेटेड एक क्वेश्चन पूछा था. How do you purge the coffer dam and how is stripping done? This must be related to your oil tankers, na?
Yeah, obviously coffer dam. नहीं but देखो coffer dam पूछ रहा है तो
it could be in the engine room as well, na sir?
Coffer dam anywhere. Coffer dam can be anywhere. Need not be कि tanker के बीच में भी है. It could be. Coffer dam is basically a white space. ठीक है?
Right.
तो stripping
ये भी उनका ही है गुलाटी सर का क्वेश्चन.
देखो you have to understand one thing that generally copper dams के अंदर unless it is next to a cargo tank or something, you would not have a pumping out connection. Okay, you might have this क्या बोलते हैं अपना जो high level alarm, ठीक है, in the coffer dam. ठीक है, कई जगह पे coffer dam में भी नहीं होता, ठीक है. You don't have any indication also. Some places you have. जैसे अगर cargo tanks के बीच में है तो वहाँ पे आपको alarm रहेगा. But the idea is he is asking you how to pump out. That means there is stripping बोला है तो stripping मतलब there is going to be a stripping connection. ठीक है, either from your COPT or from the stripping pump. So see, the word stripping means that you want to empty it fully, right? So there has to be a permanent connection only. But what exactly is the question? मतलब क्या question क्या है?
सर क्वेश्चन मतलब उसने तो इतना ही मेंशन किया है कि कॉफर डैम पर्जिंग एंड हाउ इज स्ट्रिपिंग डन.
पर्जिंग पूछ रहा है तो मतलब but why purging? Purging in coffer dam. Purging is with regards to air. ठीक है.
सर ये सवाल ना उसका है जो पंप लगा होता है जो सबमर्सिबल जो कार्गो पंप होता है सबमर्सिबल वाला उसमें होती है कॉफर डैम पर्जिंग.
हाँ ओके उसकी बात पोर्टेबल पंप का. अच्छा उसका ओके कॉफर डैम पर्जिंग जब फ्लैमो सिस्टम होता है ना पोर्टेबल फ्लैमो पंप उसकी बात कर रहे हो ना?
सर उसी की बात है.
पोर्टेबल फ्लैमो पंप जहाँ पे होता है ना तो वहां पे आपका बेसिकली व्हाट इज दिस कॉफर डैम इज बेसिकली नॉट योर ये 3-4 बार क्वेश्चन पूछा है किसी ने पूछा है कॉफर डैम पुटिंग. ठीक है, कॉफर डैम पुटिंग करके कोई किसी ने पूछा है. आई सेड लॉस्ट आई सेड नो कि किसका है ये नोएडा ग्रुप में किसी ने डाला है पॉल सर सुधीर सर. ठीक है, एंड दूसरा सुमित ने भी डाला है पॉल सर. ये सुमित का ही है बार. अच्छा दूसरा किसी का है गुलाटी सर and Srivastav sir. Now here somebody has actually said the correct thing. He has asked about copper dam purging. ठीक है, putting नहीं है purging. ठीक है. So see idea क्या है ना, where you do not have a fixed what do you call फ्लैमो पंप. ठीक है, तो वहां पे आपको एक पोर्टेबल फ्लैमो पंप डालना पड़ता है. So how is that there is a फ्लैमो पंप connection and basically the entire system where you put in the फ्लैमो पंप. एक जो उसका जो क्या बोलूंगा उसको column. ठीक है, so that column is basically not having any what do you call liquid in that. ठीक है. So in this case, now when you are going to put your cargo tank, इसका एक प्रोसीजर होता है. I will have to just open up the manual. उसमें से आपको मैं दिखा दूंगा. I will share it tonight. मैं निकाल के आपको दिखाता हूँ. उसका वो स्टेप्स है, 3-4 प्रोसेस स्टेप्स है उसका.
वो लूब वाल साइड और कार्गो साइड के बीच में ना दोनों तरफ एक एक सील होता है और सील के बीच में एक कॉफर डैम रहता है, तो वो उसमें ना हवा एक तरफ से डाल के दूसरी तरफ देखते हैं कि ऑयल आ रहा है, लूब ऑयल आ रहा है या कार्गो ऑयल आ रहा है, उस तरह से पता चलता है कौन सा लीक ऑयल सील जो है लीक.
ये तो नॉर्मल प्रोसेस ही हो गया ना. ये तो आपका नॉर्मल प्रोसेस ही हो गया. दिस नॉट इमरजेंसी प्रोसेस. This is your normal this thing process. Just give me a second. Just hold on.
वो हमेशा ही मतलब एक्सेसिबल है ना, तो चाहे नॉर्मल करें चाहे इमरजेंसी में करें.
He's talking about that coffer dam. I understood now which one. Between this thing and this thing, there is a seed section where there is nothing going to happen. I just show you a diagram. Hold on. Sorry, I was muted. I didn't realize. Okay, तो ये वाले की बात कर रहे हो ना, पर्जिंग एंड फील्ड मॉनिटरिंग कैसे कर रहे हैं, ये वाला. ये यहाँ पे आपने, ये तो एक्चुअली तो पर्जिंग वाला प्रोसेस है. सो ये वाला है आपका सेक्शनल व्यू ऑफ द नॉर्मल प्रोसेस. हाँ, ये वाला डिस्चार्जिंग का प्रोसेस है, क्योंकि नॉर्मल दिस थिंग. ठीक है. तो ये कॉफर डैम का पाइपिंग है, ये वाला आउटर पाइप. ठीक है. ओके. और ये आपका कॉन्सेंट्रिक पाइप है. ओके, नाउ आई अंडरस्टूड व्हाट इज टॉकिंग अबाउट. तो बेसिकली ही इज टॉकिंग अबाउट दिस चेकिंग. आप इसी का बात कर रहे हो ना, ये जो इसको मॉनिटर करता है, इसके आउटलेट को.
नहीं sir, I have no idea because I've never worked on tankers, so
I'm talking about Anshul.
यस सर,
Okay.
यही वाला, ये जो हवा डाल के दूसरी तरफ हवा
ये निकालते हैं ना. तो अच्छा देखो, आइडिया क्या है ना कि हाउ इज दिस पंप बीइंग वर्किंग. ये आपका टोटली सबमर्ज्ड पंप है इनसाइड द कार्गो टैंक. ठीक है. एंड दिस इज योर हाइड्रोलिक मोटर. तो हाइड्रोलिक मोटर हैज गॉट अ कंट्रोल फ्रॉम अ गवर्नर. बेसिकली पावर पैक से यहाँ पे लोकल कैपेसिटी कंट्रोलर तक आता है और उसके हिसाब से ये ऑपरेट करता है. ठीक है. एंड नाउ यू हैव गॉट this basically this purging connection to the this thing. All right, that's this one. All right. So from here you have got air connection is always going inside and this other side is going outside. ठीक है. इसके air निकलते जा रहा है. So idea क्या है कि between the cargo, the अंदर इसके hydraulic oil. ठीक है. तो hydraulic oil inwards है. Oil is going inside, operating it and going out from here. ये जो central line से वापस बाहर निकल के जा रहा है. ठीक है. So the idea being this the blue area where you've got basically just a air connection which is always continuously being purged. Okay. So this area, all right, should not have any cargo oil, neither it should have any hydraulic oil. Cargo oil is the one which is in this color and hydraulic oil is in this color. So idea is continuously it has got a trap, okay, and trap is being monitored and it is having a basically a ulta siphon tube jaisa hai to give basically if there is any liquid in that it will come out from the trap and the air is going to be basically coming out that way continuously. Okay. So the idea is you're monitoring this outlet. Okay. And if you're having any connection between the leakage between the what do you call hydraulic motor side, then the hydraulic oil will come inside this side. Okay. And you'll get the indication over here by hydraulic oil. In case your cargo side is leaking, basically there's a fuse. There is one cargo seal in the bottom and there is the oil seal on top. So if the oil seal leaks, the oil will basically come out into the outside. And if the cargo seal leaks, then cargo will come out into the side. So ये idea वही है कि how it is being purged. So basically continuously it is being purged. तो इसलिए मेरे को पहले समझ नहीं आ रहा था कि कार्गो कॉपर डैम पर्जिंग, कार्गो कॉपर डैम में कोई पर्जिंग तो होता नहीं. But he is basically talking about this coffer dam. Okay. So where you've got a system like this. So this is your Framo system. ठीक है. तो फ्रेमो में ऐसा ही होता है. ठीक है. So this is your entire system. ठीक है, केवल आपको समझा मैं क्या बता रहा हूँ अभी यहाँ पे?
हाँ हाँ सर.
So अभी इसके अंदर how is the final stripping of the main cargo done? See, once you have completed your maximum cargo, the level will keep on dropping. ठीक है? So then यहाँ पे ये some amount of unpumpable will left because ultimately the centrifugal pump. ठीक है? It will stop its suction at a particular head. ठीक है? Suction head जब उसका break हो जाएगा, it will basically not able to take that column, lifting column में नहीं जा पाए. ठीक है? So at that time you still have got amount of cargo in this column, okay, and unpumpable inside the what you call cargo tank. ठीक है? तो ये अनपम्पेबल को निकालने के लिए देखो क्या किया हुआ है, यहाँ पे एक कनेक्शन दिया हुआ है कंप्रेस्ड एयर. ठीक है? एंड ये आपका मेन कार्गो वॉल बंद करने वाला है. ठीक है? तो ये मेन कार्गो वॉल बंद कर देते हैं. ओके, एंड देयर विल बी सम अमाउंट ऑफ अनपम्पेबल इनसाइड दिस अलोंग विद द टैंक, एंड देन दिस वन सेपरेट लाइन इज देयर. दिस इज कॉल्ड द कार्गो स्ट्रिपिंग लाइन. So cargo stripping line will be opened. Okay, then this wall will be closed, somewhat like this. All right, this wall is closed. Cargo stripping line is open in this case. Now what happens as I put the air, it will start moving it down, whatever the cargo. And now when this flows, this part acts like a ejector, sorry, like a ejector, and basically it creates a partial vacuum on this side. It will take whatever is cargo inside this. It will basically pump that out, and it will take it out from the system. That is the way it works. So that's why you do not require the separate stripping connection inside this type of a tank. Okay. And even when this thing is going on, you see continuously the hydraulic flow is there, and the hydraulic flow is being maintained, and this purging connection is always being maintained because it's always being monitored. That is the way. Okay. And finally, once it is stopped, you're basically still having your what you call air in and air out. Means continuously this purging is always being done, and monitoring of the seal is always being done, irrespective whether the hydraulic oil flow is active or not. So this is the condition when it is totally dry. Still there will be about 1% or 0.1%, 2% in the cargo which is remaining, but the entire column and most of the oil will be removed. Okay, that is the idea. So ये stripping connection के बाद भी ये wall बंद करने के बाद ये वाला wall बंद कर देंगे, ये वाला wall बंद कर देंगे, and continuously you will keep monitoring the coffer dam space. That is right. Okay. That is how your FAMO system works. Now, just give me a second.
सर आप म्यूटेड है शायद.
Okay, तो hydraulic power unit के अंदर ही this is all the pumps which are there in your hydraulic system. ठीक है, in your FAMO system. ठीक है, तो ये जो hydraulic power unit है इसी के अंदर वो आपका जो क्या बोलते हैं jockey pump है.
Yes.
Inside this one. So it is not a separate standalone feature. It is not going to be there. That's why I say as per regulation, it need not be even separately indicated in your diagrams. Okay, it is a part of the power system. And what are types of pumps you can have? You can have a portable FAMO pump. Okay, you can have ballast pumps for that. You can have basically cargo pumps. You can have a separate tank cleaning pump, basically a small centrifugal pump. Okay, then you can also have basically different sizes. Okay, that again for one different type of this was rock tanks, and this is for cargo tanks, bigger capacity, 150 meter cube and 300 meter cube, and then about 500 meter cube, larger varieties. Okay, and then you got the deck window system also given by the power pack, same thing. And then the hydraulic bow thruster is also there, which is also supplying the from the same system. Okay, so you got deck which is in the aft deck as a forward deck. Basically, they both of them are supplied by one power pack only. Okay, this is inside the engine room. Okay, this is the engine के अंदर ही आपका ये engine room के अंदर है at the side. This is the entire system for your prime equipment hydraulic system. ठीक है, आई जस्ट कंफर्म कि ये हाइड्रोलिक पावर पैक के अंदर था, ये इसका जो जॉकी पंप है, क्या टाइप का पंप है. तो somebody had told me once that it was a small gear type pump. ठीक है, the gear pump तो doesn't make a jockey pump. Jockey pump is generally a centrifugal pump only. ठीक है, we will just confirm what type of pump this is and I'll get back to you by tomorrow.
जॉकी पंप अपना इसमें भी रहता है ना, जो स्प्रिंकलर फायर का जो फायर फाइटिंग सिस्टम रहता है, वो हाइपर मिस्ट.
आपने देखा है अंशुल?
मैंने पढ़ा है सर ऑनलाइन, लाइक बोल ऑनलाइन बोल रहा था.
देखो ये ऑनलाइन मैं और ये अपना केयूर ने भी देखा था. ये एक मिनट हो गया, देखो ये दिया हुआ है, देखो यहाँ पे ये देखो, ये बोल रहे हो ना आप, ये सब जगह नेट पे ये दिया हुआ है. ये जॉकी पंप इज बेसिकली मल्टी स्टेट सेंट्रल कनेक्टेड फायर स्प्रिंकलर सिस्टम इंटेंडेड टू मेंटेन प्रेशर. यही वाला है ना, ये वाला पढ़ रहे हो आप? ठीक है, अभी ये वाला जो पंप है ना, ये जो फायर फाइटिंग पंप है, ये इट इज नॉट फॉर मरीन यूज. ठीक है,
सर ये एक्चुअली ये वहाँ यूज होता है जहाँ पे आपकी लाइंस हमेशा प्रेशराइज होती है, और इन केस ऑफ अ फायर आपकी जो नोजल होती है वहाँ पे एक बल्ब होता है विच विल ब्रेक एंड इट विल ऑटोमेटिकली स्टार्ट फायर फाइटिंग. अपने केस में ऐसा नहीं होता है, द लाइन इज नॉट प्रेशराइज्ड एट ऑल टाइम्स. The pump will start after the fire has been detected and a solenoid valve will open and all that.
No. एक मिनट. Accommodation स्प्रिंकलर अपना भी वैसा ही है.
अपने में सर वो एयर से उसको प्रेशराइज करके रखते हैं.
एयर से प्रेशराइज करके रखते हैं, वही तो मैं बोल रहा हूँ ना. ओनली डिफरेंस हाइड्रोफ्लो है ना अपने में, तो अपने में जो मेन लाइन प्रेशर है वो कम नहीं होगा. ये कहाँ पे है ना, दिस इज बेसिकली फॉर सिस्टम विच आर कनेक्टेड टू योर अंडरग्राउंड सब व्हाट यू कॉल जो सबटेरेनियन जो सिस्टम होते हैं ना, जिसके अंदर आपका जो बेसिकली म्युनिसिपैलिटी का पानी जिधर आ रहा है. ठीक है, सो आइडिया क्या है कि वेयर यू हैव गॉट दैट पावर, दैट वाटर कमिंग फ्रॉम योर सम अदर थर्ड पार्टी सिस्टम. ठीक है, तो अगर वो वाटर प्रेशर उसके अंदर कम हो गया, तो अल्टीमेटली योर लाइन प्रेशर इनसाइड योर entire what you call system will also reduce, and you do not want that pressure drop to occur, and that is the reason that is given in where you've got a fire pump system in your accommodation, or not accommodation, your offices and everything ना, तो वहाँ पे ये jockey pump होता है. ठीक है, basically to not allow your, this is not for ships, it is not there in your ship. ठीक है, I have just seen in your entire sprinkler system जो है ना, उसको भी देखा, और मैंने ये भी देखा क्या बोलते हैं अपना जो हाइपरमिस्ट सिस्टम में एक पंप है और देयर इज नो अदर पंप इन हाइपरमिस्ट सिस्टम. ठीक है, वन सेकंड, आई जस्ट शो यू. होगा, it is not there in sprinkler, neither it is there in your hypermist system. One second. Piping systems, local water hypermist system. So you see, this is your local water firefighting system, C plus का है. Only one centrifugal pump, CR513, Grunt Fundus का है, EBS approved. Okay, no other pump is there. Blowing air connection ये वो है, and controller है, water mist repeater, local switch, water mist nozzle and everything. No other pump is there basically. See here. Spare part, nozzle, flame detector. One second, I'll show you the entire.
नहीं इसमें नहीं है सर, एडिशनल पंप नहीं होता है, एक ही पंप होता है।
ये पंप है ना यहाँ पे अपना बड़ा पंप है, एक सेकंड, तो देखो ये पंप है, ठीक है, दिस इज अ बिग पंप एंड दिस इज लाइक इसका दिया रेटिंग दिया था टू 3 into 180 बार ये वाला है, देखो अपना, ठीक है, पावर फैक्टर, ये मोटर एफिशिएंसी, ये एंड 4 किलोवाट का मोटर है, ठीक है, आज बिग वन है, दिस इज नॉट योर एडिशनल, हाँ दिस इज द पावर, ठीक है, इट इज लाइक अ 55 kg पंप, बड़ा पंप, दिस इज नॉट लाइक अ एडिशनल पंप, मतलब ये लगता वैसा ही है जैसा आपको दिख रहा है कि एक मल्टी स्टेज पंप है, बट वो वाला जो मल्टी स्टेज पंप होता है उसका जो थर्मोकोल होता है बहुत छोटा होता है, इट इज नॉट अ लार्ज सिस्टम, तो बेसिकली वो entire stage नहीं है, this is not there in your ship systems, but again let me just confirm it, I confirm it tomorrow तक मैं देखता हूँ, ये दूसरे मेरे पास मैनुअल्स भी हैं इसके, but yeah the idea is that it is there for that. Any of you has done a dual fuel engine? I think Geo आपने किया है ना?
हाँ सर।
तो उसमें भी आज वाट सर ने पूछा है how gas ignition takes place in XPR, ठीक है, I would suggest don't go into dual fuel unless and until he asks you, okay? I think
Yes sir, yes sir.
this guy must have told के dual fuel किया है, because many pilot fuel का gas वैसा है, because बहुत सारे उसके अंदर फिर वो आते हैं क्या बोलते हैं सेफ्टीज के ऊपर चले जाते हैं व्हाट्सएप, and then it becomes about the monitoring of the double walled pipes and everything, उसका कंस्ट्रक्शन कैसा होता है,
Yes sir, yes sir.
वो उसमें वो खा देते हैं आपको, तो I would not recommend you unless you are very thorough with it, ठीक है, and then okay, because अगर वो starting में अगर वो पूछ लिया तो फिर वो प्रॉब्लम हो जाएगा, ठीक है, alright, let's go upon our continue with our same system, तो हम लोग कर देते हैं air starting का, just give me a second. I believe हम लोगों ने we had completed the lost motion clutch, right?
Yes sir, yes sir.
Man BW का reversing बचा. Before that, let us see the fuel cams of Man BW and Sulzer. Just give me a second. Okay, before that, Kevin, were you there when we had discussed about cam nomenclature?
No sir.
Okay, we just cover this also because before that, अगर हम लोग cover करेंगे तो आपको कुछ समझेगा नहीं जब हम बात करेंगे. There is this one file I believe on the group, cam nomenclature. I think. Anyways, I will share it today afterwards if it is not there. Okay. So you see, here there is basically a cam follower and a cam. Okay. So this is a very old design, basically a rotating cam and transiting follower. Basically, the cam basically follower is just going vertical up and down. Okay. So the cam basically just going up and down. This is basically the very old type of a design. Then what they did, they started putting a basically a roller on top of your cam, so that now you can have basically your cam follower in any position, and you'll have an oscillating design. That means as per the movement, it will basically move up and down, and you can get a motion which is oscillate. Okay, that is right. Now nomenclature of the cams. Okay. Now you've got something called as a pitch curve. You've got something called as a prime circle. You've something called as a base circle, and something called as a cam profile, and then something called as a follower travel. Okay, and there is something called as a pressure angle. Pressure angle is not really very important, but cam profile कभी कोई पूछते हैं और ये pitch curve क्या है पूछते हैं. Okay, so we'll just go over the things which are there. Trace point, a theoretical point of the follower corresponding to the point in or a fictitious knife edge follower is generating the pitch curve. So basically, अगर आपका जो follower actually travels along the entire basically cam, okay, the entire profile. That means even the base circle and the what do you call this thing, you know, the entire cam के ऊपर अगर आपने follower को घुमाया, so that tracing out of where the follower center rotates, that is called as a pitch curve, okay, or a trace point, okay. And basically the trace point generates the pitch curve, means the where the with the pitch curve is moving, okay, with the trace point is basically at any given instant where the follower is there onto the cam, that point is called as the trace point, and the trace point का अगर पूरा आपने घुमा दिया तो उसको it is pitch curve बोलेंगे, where the cam follower is supposedly going. Actually, cam follower is not moving, the cam is moving, right? So in case of the roller follower, the trace point is in the center of the roller. So basically, in case of the roller follower, always the trace point is center of the roller. Okay. Now pitch curve, the path generated by trace point is the follower is rotated around a stationary cam. So अगर a stationary cam है, अगर ये घूमता, ठीक है, so then that would be a pitch curve. But now what we have is basically the cam which is moving and the follower which is moving up and down. Okay, so that's why what you will have is basically only a follower travel. Basically, as a follower going up and down. Okay, that is the idea. Then working curve, the working surface of the cam in the contact with the follower. For the knife edge follower, the cam plate of the plate cam, the pitch curve and the working curve coincide. In a closed or grooved cam, there is an inner profile and outer working profile. As we saw for the for the starting and distributor man point of view, they have got this inner and outer profile working curve. Okay. Now there's something called the pitch circle. The circle from the cam center to the pitch point. The pitch circle radius is used to calculate a cam of minimum size of a given pressure angle. So basically, at a particular pressure angle, okay, when that basically we draw a circle, okay, from that basically becomes your pitch circle. Basically, where your follower is going across. Okay, that idea. That is the idea of the pitch circle. Now then the prime circle, for the reference circle, is smaller circle from the cam center to the pitch curve, basically prime circle. So basically, where the basically follower would, if it be rotating around the cam, okay, then the smaller circle, basically where it is going onto the whichever is the lowest what you call onto the base circle, basically that would basically what is the diameter. So this part is the prime circle, basically the smaller circle. Okay, and the remainder when it is going up and down, that is basically the pitch curve. Basically, that is the idea. Okay, and base circle, the smaller circle from the cam center to the profile is the same as basically base circle. अभी जो cam का सबसे छोटा circle हो गया, that is the base circle. Okay, always the base circle is the smallest circle of the cam. Okay, and the largest is the cam profile. Okay, the cam profile is the entire profile which is there, and the base circle is the smallest one. Okay, then follower display stroke or throw, the greater distance and angle through which the follower moves or rotates. So like here you have the follower travel here is up and down. In this case, that is the follower or throw or the travel, basically vertical movement. That is the idea. Then pressure angle any point when the normal or the pitch curve and adjusting the cam profile. मतलब basically अगर cam profile के ऊपर रख के आपने अगर आप moving in the rising flank or the falling flank wherever your rotation is there, so that angle it makes with the center, okay, that and there is a basically angle vertically opposite angle. That angle is basically called as the pressure angle, where the follower makes with the basically with the center, the line passing to the center. तो एक बेसिकली एक एंगल यहाँ पे आ गया और एक एंगल यहाँ पे आ गया, तो वर्टिकली ऑपोजिट एंगल की बात कर रहा है, तो वो प्रेशर एंगल हो गया. This is the basic idea. So you have to understand what is the base circle. Okay, if you are operating in a clockwise fashion, then this would be the rising flank and this would be the falling flank where it is coming back to the base circle. Okay, so you can have a positive cam or a negative cam. Okay, so positive cam will be basically having always the basically what we have. What type of cam is this?
This is a positive cam.
See, all depends on which is defined as a what you call where the action is happening. So the action is happening as it is leaving the base circle, okay, and is staying on the positive side onto the entire cam profile, and again coming back over here. So this is a positive cam. Okay. Negative cam में क्या होगा कि it will come down like this. But I will show you some angle from some cams, and you might get confused in that. Just give me a second. Alright. So now what we have here is your man BW MC fuel pump. Okay. This is your man BW MC fuel pump cam. Okay. So here what we have, I believe, did we complete the reversing of this man BW fuel pump? How it happened?
No.
नहीं किया था ना? Okay.
नहीं.
So idea क्या है देखिए, here you see the cam is basically going to go in this clockwise direction in the ahead direction and anti-clockwise in this direction. Okay, that like this. So you have, when you're going in the clockwise direction, all right. So now this is going up, this becomes the rising flank. Okay, this is your base circle. If it is leaving the base circle, it is going on to the rising flank. And now basically there is a dwell period where there is no action. Okay, and the dwell period is around 280 degrees. Then again the 35 degrees is the falling flank. Okay. So what is happening is basically as it is going from here, the pressure build-up starts. As it starts leaving the base circle, it starts building up the pressure, and it reaches the maximum height onto the cam at this point at 35 degrees from here, right? And then from here, it stays at that position right up till here, to the entire position of 280 degrees, and again it starts falling. Okay, that is ideal. Similarly, in anti-clockwise direction, when it is rotating, this becomes a rising flank, okay? Because now your cam is rotating in other direction. So now the rising flank becomes this thing, and now it is traveling at 280 degrees, okay? And it is coming onto the falling side. So this is your man BMW MC fuel pump, okay? So basically, वही दिखाया हुआ है, देखो कि we talk about reversing again. What is there? Okay? And then
Sir,
हाँ.
सर एक ये क्वेश्चन भी पहले ऐसे पूछते थे कि why is there such a large क्या dwell period on a man BMW cam?
Yeah, I'll come to that. One thing, I'll come to that. You see,
Okay.
idea क्या है? देखो, this is your man BMW fuel cam, ठीक है? Here the total cam angle is 350 degrees, ठीक है? 350 degrees is the cam angle. Now what I want to show you is the Sulzer fuel cam, ठीक है? Now Sulzer fuel cam is only 140 degrees total, ठीक है? And now which is the base circle इसके अंदर? Is it this or is it this? Which is the base circle? Base circle is again, all right?
The same, sir. Yeah.
Same only, ठीक है? Base circle is the smallest circle on the profile, right? So cam profile is above here, ठीक है? ये
Yes,
भी
sir.
positive cam है, ये वाला भी positive cam है. Here, as it leaves the base circle, it is starting the operation, okay? And remaining for 280 degrees, it is pull up, and then 35 degrees it comes down. In this also it is similar. Base circle says it starts operating from here. This is the profile where the cam profile goes up. So ये अभी rising flank इसमें ये हुआ, ठीक है? And that is a 30 degree. 21 degrees is the rising flank, and 9 degrees is the actual where it is going up to the profile, ठीक है? And then it is basically staying about 80 degrees where it is a dwell period, okay? And again 30 degrees is the falling flank, and it is steading. There is again basically no action for the remaining this 220 degrees, okay? ये जो बीच वाला degree. So that's why the entire cam angle is basically less in this case, okay? So basically total cam angle of 140 degrees positioned about TDC, giving 98 degrees of asymmetry after TDC. Hence reversal angle is 98 degrees. Okay, so that's why you require this total 98 degrees to be reversed. So total 140 में से ये जो 98 है पूरा घूमना चाहिए, और that is done by that lost motion clutch. Okay, so that's why you got that lost motion clutch where you require that much amount of the variance of the entire camshaft. That means by 98 degrees it is to shift. Okay, okay. So your dwell period to 80 degrees है where nothing is happening above here, where it is at the maximum stroke is above here, all right? Similar उसके अंदर 280 degrees का dwell period था, ठीक है? उसके अंदर यहाँ पे 280 degrees का dwell period था, where there is nothing happening, okay? And this basic part where it is there onto the base circle, मतलब ये जो आपका ये 10 degree है, ये 10 degree does not take part in the actual pumping, तो इसलिए इसको पूरा नहीं गिनते, ठीक है? Otherwise देखो कैसा है ये 280, ठीक है? 280 plus 60, ठीक है? 280 I do it 280 plus 30 plus 30, that becomes 340. तो मतलब बेसिकली क्या हुआ कि ये बीच का ये जो 30 डिग्री है, ठीक है? ये जो 10 डिग्री है, ठीक है? इसको हम लोग गिन नहीं रहे. तो टोटल 350 डिग्री एंगल है, जिसमें से एक 10 डिग्री हम गिन नहीं रहे, ठीक है? इसलिए टोटल व्हाट यू कॉल दिस थिंग 20 डिग्री गिन नहीं रहे, ठीक है? 10 डिग्री ये साइड पे, 10 डिग्री ये साइड, ठीक है? तो टोटल आपका 330 डिग्री का आपका रिवर्सिंग एंगल. So the idea is there, here the reversal angle is only 98 degrees, and here the reversal angle is 330 degrees. Okay? So the idea is it not easier to move this cam follower from this 10, 10, and 10 rather than this entire, this thing moved from the angle of 330 degrees. Okay? So that's why what they're doing is instead of moving the cam, here what they're doing is they're moving the cam follower. So cam follower is moving from the 10, 10 and 10. This 10 and 10, 20 degrees, it is shifting. Okay, so 30 degrees, it is shifting from the total 360 degrees, 10 degrees, 10 degrees, 10 degrees, 30 degrees, इसको shift कर रहे हैं, ठीक है? और ये total reversal करते हैं, So this is done by a separate system where it is controlling a hydraulic system which is controlling this what do you call system.
Follower.
एक कैम फॉलोअर के बीच में एक सिस्टम होता है जिसमें से ये फ्यूल पंप कैम रोलर का पोजीशन ऑफ point of contact, it is shifting. So rather than moving the entire cam from 330 degrees, it is moving only this particular point, from this point to this point. So ये 30 degrees move करता है, 10 degrees on the falling flank of this, 10 degrees on the base circle, and 10 degrees on the rising flank of this. So it measures this from this to here. Okay, that is what is happening. So मतलब अगर ये cam same shift रहेगा, cam उधर का उधर रहेगा, the entire follower will shift from this 30 degrees. So it is shifting from 30 degrees. It is basically getting that entire, giving the same thing. ना? जो आपका reversal angle जो 360 degree, 330 move करना है. Instead of that, now the follower is moving. So that is the reason why that आपका जो dwell period है, इसके अंदर इतना large है. ठीक है? You want it to be as large as possible, ताकि you don't want the basically the entire cam angle to be smaller. ताकि you want this to be as small less as possible. ठीक है? That's why the base circle पे 10 डिग्री. यहाँ पे क्या है देखो base circle पे ही आपका खाना इतना ज्यादा जगह है. ठीक है? 220 degrees and then the 220 plus whatever this angle is there. ठीक है? तो basically 140 degrees यहाँ से लेके यहाँ तक होता है. ठीक है? That is what is happening. No, 80 plus 30 plus 30. तो basically वो कोई कर रहा है. तो इसलिए so that is that. ठीक है? So you understand the idea why that 12 period is so large and this 12 period is less.
Yes,
because
yes, yes.
they want the entire cam to be moved.
So basically, इसमें we can answer कि it all depends on what kind of design principle they are incorporating in the reversing of the engine in the camshaft.
Exactly. If you are
Okay.
moving the roller point of contact or you are moving the actual cam.
Right, sir.
If cam is moved, then dwell period is too small. Okay. If the roller is to be moved, then dwell period. If the cam is to be moved, the dwell period is sufficiently large. Okay. So that is the only thing where it is moving. The cam is actually moving. Okay. But अगर आपको roller point of contact move करना है, dwell period has to be dwell period नहीं, base circle has to be very small and dwell period has to be sufficiently large. Okay.
Right.
I just misspoke. So basically, where your base circle is small, the dwell period is large, and that's why you are moving it on the base circle. Means आपका ये 10 degree, 10 degree, 10 degree ये आप change कर रहे हो, ठीक है? And in this case, you are moving it. The entire cam is moved across the dwell period. That's why the dwell period is smaller. A total about 98 degrees. So ये 30 plus ये 80, and then 9 is basically 9 plus 9, 18, and 80. तो वैसा करके वो इधर से इधर move हो जाएगा. That is the idea. So 9 degree of this side, 9 degree of this side, and then 80 degrees. So that is the reason you are not allowing it to go more. That's why in this case the lost motion clutch is moving it, and here you can't move it across the base circle. Base circle से move किया तो base circle पे तो बहुत बड़ा angle है ना, 220 plus whatever is this angle and this angle. So maybe around this must be around 30 and 30, 60, 45. ये 60 degrees होगा यहाँ पे, 60 plus 60 plus 220 because 360 degree complete करने के लिए वैसा होगा. So you have to think about it that way. ठीक है? So that is the reason you wanted to move it across the what do you call the dwell period in this case, and in this case you wanted to move it across the base circle. So cam के profile पे depend करता है. ठीक है? That is the idea. So that is why idea क्या है कि what is shown here is basically this is the TDC position in middle. ठीक है? ये वाला position जो दिखाया है कि 10 degrees past TDC where your actual head pump injection starts. ठीक है? That is the idea. That's why this rising flank का 10 degrees है और इसके अंदर 9 degrees है. ठीक है? कि 9 degrees past your TDC position it starts. That is the idea. तो ये आपका MC का है और ये सल्जर RTA का. ठीक है? That is the idea. So if I want to categorize, I will say up to RTA, fuel pump cam has got one cam for fuel pump and one separate cam for starting a distributor, and both were moved by the lost motion clutch. Okay. Then RTA and after RTA, you had got basically a separate individual cam for two separate individual cams for head and stern for fuel pump, and you are doing the horizontal shifting of the cam, ठीक है, not by the lost motion clutch, ठीक है, दो individual cam आ गया तो उसको आपको horizontal shifting करना पड़ेगा, ठीक है, and then your starting air distributor again had two cams, ahead and astern, and vertical shifting. We have seen that, I think, believe that vertical shifting of the cam. I'll show it again today. RTA का जब बात करेंगे. And then B&W has got basically a single cam follower, basically like this. Okay. And here for the fuel pump, you're moving the roller point of contact along the basically along the base circle. And for the starting air distributor, you've got the horizontal shifting. We had seen that the horizontal shifting of the entire the profile. Either you're moving the basically two cams you're having, or you've got one cam with a double profile, मतलब जो dual profiles था, inner and outer race, वैसा type का design, ठीक है, that is the idea. Now let us just talk about, just give me a second, some characteristics of your air starting cams. Okay. So air starting cam with characteristics. The cam or starting air distributor is designed to provide rapid opening and closing of the starting air valves at precise timing, keeping in point the following points. So they ask what are the characteristics of air starting cam. So yeah, okay. Air admitted in the cylinder during the power stroke to provide positive start from any crankshaft position and some overlap in the timing between the cylinders. Okay. Had we discussed the overlap का formula क्या है in the starting?
Yes, yes, sir.
Number of units and everything वो discuss किया था. Then starting air admitted in the cylinder according to the firing order. The effective opening of the starting air valve is after TDC. Okay. And air starting valve must be closing before the exhaust commences. That is the idea. This is about the air starting cam profile. Then types of bearings is basically white metal bearing, bullpush shells, medium size, and camshaft bearing lubricated by oil from return of the engine lubricating system. In case of fuel leakage from pump, could contaminate the fuel oil. ये आपका जो separate ये जहाँ पे camshaft oil separate system होता है. In large engines, camshaft will understand keep bolts must be inspected for tightness, bearing slackness, wear down. ये तो आपका जैसे inspection के बारे में बात कर रहा है. ठीक है. Now fuel cams का क्या है? Fuel injection systems are designed to raise pressure of the fuel to sufficiently high value to ensure adequate dispersion of the combustion chamber to admit the fuel in the combustion chamber at precise moment and at a precise rate to cut off the fuel supply according to the output required from the engine. Okay. The profile of the fuel cam is designed to satisfy above requirements with smooth acceleration at beginning of the stroke to avoid heavy mechanical load on the injection system and to provide uniform velocity of the plunger during fuel injection. Once the needle valve opens, there will be tendency to drop in the fuel injection pressure. Fuel pump pressure must be maintained for uninterrupted injection. Uniform deacceleration to bring the plunger to at rest at the top of the stroke. The return stroke of the plunger means on the downward profile or on the base surface, okay, onto the cam profile. Sorry, plunger is a filling period. The requirement for the cam return profile need not be the same as that for injection. New directional engines may have the trailing crank design with slow return of the plunger. If the engine is a direct reversing, the fuel cam is also made asymmetrical. Okay, so as we saw that asymmetrical is 98 degrees for this thing, and that is what 30 degrees for the this one. Okay, ये inlet exhaust cams का profile है 4-stroke, ठीक है. Okay, just take a listing of the inlet exhaust cams का profile. Then okay, that is the idea about the objectives of your thing and cam profile and everything. So see, this is your camshaft driving system for a 4-stroke engine. One second. So this is a camshaft driving gear for a 4-stroke engine. I think ये Wärtsilä का है, Wärtsilä 32 का. Yes. तो ये main crankshaft है. यहाँ से आपका यहाँ पे आपका main आपका जो first ये जो wheel है, ये gear wheel है, which is basically coupled onto this. And then you have got your second gear and then third gear. And basically this is your final camshaft. ये आपको camshaft number 2 है, I believe. Going on to this thing, or it is other way around. I've told number 7 is crankshaft. Number 2 is this should be camshaft. Yeah, this is camshaft. Okay, ये वाला idea. So idea क्या है कि this is how the camshaft drive is there. From basically you have got your entire what do you call gear drive. Okay, for your main engine generator, and this is your entire camshaft system for the what's the engine again. Okay, and this is unidirectional engine. That's why it doesn't have that shifting system for the entire camshaft. Again, ये was not a unidirectional engine, then you would have that reversal mechanism what we discussed previously. So it's basically a solid system, basically nuts and bolts connected to both sides of the entabulation and basically holding it back. ठीक है, ये वाला चीज, ये वाला जो व्हील है, ये नंबर 6, ये आपका ये वाला है, यहाँ पे ये वाला जो फाइनल वाला है, ये गियर ड्राइव. That's how the camshaft system is arranged. And you have got these लोकेटिंग पिंस, 11 नंबर गाइड पिंस. तो बेसिकली ताकि जो आपका जो ओरिएंटेशन ना, ईच एंड एवरी कैम शाफ्ट का जब ओरिएंटेशन है तो वो डिजाइन्ड विद दिस, यू गॉट गाइड पिंस इन ईच ऑफ द डिफरेंट फ्लैंजेस जस्ट कनेक्टिंग योर इंटरमीडिएट सिस्टम, बेसिकली दैट वे, ताकि वो उसका ओरिएंटेशन चेंज ना हो. दैट इज बेसिकली हाउ योर. And I'll just show you an exhaust cam. I do not have the exhaust cam angles, but this is how the exhaust cam looks like. If you want to, somebody asks you how it looks like, man point of view. This is your man point of view fuel cam, if you've seen these angles, and this is how the exhaust cam looks like. Okay, this is the profile. I can find out the angle, but I think it is something like there is about 3 degrees or 4 degrees of asymmetry between this. But not too much. Not too much asymmetry because आपका जो it is mostly symmetrical. Only 2 or 3 degrees on one side. Like external running का थोड़ा सा उसमें asymmetry है, वरना otherwise it is almost symmetric. Okay. Just give me a second. Right. So Sulzer का ये देखिए, this is your vertical drive for the starting air distributor. Just hold on, somebody at the door. Hold on. This Sulzer RTA का vertical drive है for the starting air distributor. What you have here is your starting air distributor, and this is your starting air distributor का your cam. ठीक है. So you see Sulzer का ये वाला cam है, ये वाला. ठीक है. This is the cam for the starting air distributor. So you see there are two profiles, one profile on this side and one profile on this side. That means this has got two cams, and vertical sliding of your starting air distributor happens. And vertical happens basically where you have got this entire thing is connected to a basically a bevel gear connected to your camshaft, and this is basically transmitting the motion upwards. Yeah, and this is operating radial starting air distributor here. So what happens is when you want to operate it up and down, there is basically a servo motor on this end. Basically push this in and out, and basically this will slide inside this liner, and as it slides in the liner, it will basically at one time this starting air distributor will be on this profile, another time it will be on the other profile. Okay, that is angle, and you've got the vertical movement of this entire thing, and that is how your starting air distributor what you call cam looks like in your starting air in your Sulzer. Okay. Now this is your entire lost motion clutch. This is how the lost motion clutch looks like actually. Okay, like this is the entire central ये and this is आपका जो पूरा hub mechanism, and this is how one of the cams is there. Which cam is this? Fuel cam is shown here. Okay, Sulzer का fuel cam जो दिखाया हुआ है यहाँ. Okay, and this is connected to the camshaft. So ये camshaft से flange system से लगा होगा, and basically this is how the entire thing is there. This is your lost motion clutch, the entire lost motion clutch, and this is going inside your gear housing. Okay, gear housing में जाएगा. These are connections for the hydraulic oil, basically going on either side of the lost motion clutch. जैसे हमने कल देखा था. This is the entire thing, how it looks like, and the movement in the from one direction to another direction. This is how it looks like, and this is how it is inside this. ये इसके अंदर होता है क्रॉस मोशन. ये लास्ट फॉलोअर जो आपका जो जो फाइनल गियर है ना उसके अंदर. This is your muff coupling which is there. This again I'm talking about the checking of the this thing क्या बोलते हैं lead of क्या बोलते हैं इसको अपना backlash. ठीक है. And ये वही वाला आपका वर्टिकल स्लाइडिंग ऑफ दिस थिंग इज देयर. ये स्टार्टिंग एयर का डिस्ट्रीब्यूटर का फंक्शन दिखा रहा है, स्टार्टिंग एयर वॉल का, पर आइडिया वही है. ठीक है. दिस इज अबाउट योर सॉल्वर दिस थिंग एंड दिस थिंग. आई जस्ट शो यू वन मोर थिंग. Now man BW moving of the point, roller point of contact is done by this method. So this is your fuel cam, and fuel pump moving of the roller point of contact is run by a pneumatic cylinder, which is moving this rod, and it is move it left and right. It is going to move the roller point of contact. Okay, and this is how it looks like in the actual this thing. Okay, ऐसा इसका connection system होता है. Okay. Safety features and interrupting devices. Okay. We have completed this. Now let me just talk about Salgar. Just give me a second. So you see, this is the entire control system for the servo motor for your what you call lost motion clutch, and that is basically as you operate this. Okay, ये आपका reversing cylinder है. Okay, this is actually operating the entire lost motion clutch. ठीक है. तो ये आपका system है which is giving the start, stop, ahead, astern switches. ठीक है. And this is a remote system. This is a mechanical system. In case the remote system fails, this is going to take over. So idea क्या है कि it is going to give the oil, sorry, the air to either side of the this what do you call servo cylinder, and it moves that is going to change the oil response to the this is the starting air servo cylinder and this is the fuel air servo cylinder. So ये आपका जो starting air का separate servo cylinder है, horizontal shifting, which I just showed you, it interfaces with the what you call basically system. एंड ये जाके देखो यहाँ पे ये आपका कैम शाफ्ट को हिला देगा. ओके, एंगल से, एंड दैट विल बेसिकली देन गो एंड मूव योर स्टार्टिंग एयर डिस्ट्रीब्यूटर. ठीक है, अप एंड डाउन, व्हिच वी जस्ट सॉ के वर्टिकल मूवमेंट ऑफ योर स्टार्टिंग एयर डिस्ट्रीब्यूटर, उसको जो होता है वो ये आपका ये रिवर्सिंग सिलेंडर से होता है. ठीक है. सो आइडिया क्या है कि यू हैव गॉट योर ऑयल गोइंग इनसाइड दिस रिवर्सिंग सिलेंडर, गोइंग इनसाइड योर सर्वो मोटर. सर्वो मोटर मूव करता है, सर्वो मोटर ट्रांसमिट्स टू द कैम शाफ्ट, एंड कैम शाफ्ट के साथ में बेवल गियर सिस्टम से starting air distributor को move करता है. ठीक है. So depending upon that, this entire thing moves up and down by that separate servo cylinder on top, as I told you. ठीक है. उसके एक separate servo cylinder है ahead astern के. So ये एक आपका servo cylinder हो गया lost motion clutch का, और ये आपका starting air distributor के जैसे bevel gear से जा रहा है. ठीक है. And this is the actual reversing servometer principle जो कैसा काम करता है कि oil going and coming and outlet is basically on the center. ठीक है. And basically ये आपका fixed to the camshaft we saw. Big bolts are basically going through the entire this flapper of this servo cylinder. Okay, ये वाला जो है वो through and through, ताकि ये इसको ऑपरेट करता है, और ये वाला आपका स्टेशनरी पीस है. ठीक है. कैमशाफ्ट के स्लीव के साथ में स्टेशनरी. That is right. This. Okay, let us talk about the entire maneuvering diagram for your main engine. Okay. Alright. So this is your man-made MCC maneuvering diagram. ये again मैंने खुद बनाया हुआ है, understanding interpretation from your main engine का जो system है, ठीक है? So what we are the components will just see here. ये आपका starting handle है, showing 3 positions: run, stop, start. Okay. Stop is the instantaneous signal, start is the instantaneous signal, run is a variable signal. Okay. Then you have got basically interlocks. The one interlock is here, and a secondary interlock is over here. Then you have got the reversing handle. Basically ahead astern stop is in stop बीच में नहीं होगा, ahead astern पे ही होगा हमेशा. ऐसे ये stop बीच में position नहीं होता, ahead astern पे ही होता है either one. Then you have got the fuel pump reversing cylinder, which we just saw, the reversing the roller point of contact for the fuel pump. Fuel pump है, fuel pump के ऊपर puncture wall है, governor है. And then you have got the horizontal sliding for the starting and distributor, shifting the 2 cams. ठीक है, जैसा हमने देखा था head profile, astern profile, ठीक है, उसको move कर रहा है. या तो आपका जो 2 cam नहीं है तो single cam का है, double groove वाला system है, उसको control कर रहा है, जैसा हमने देखा था starting and distributor. ठीक है. Then you have got something called the block wall. Okay. Idea क्या है कि only one side से there will be a signal coming out. We'll understand that. Okay, later on. And then from there is some one more interlock is there. And once that is satisfied, then there is a pneumatic cylinder coming to the. What I have not shown here is the entire operation of the auto start valve. I've just represented like this. So this is the actually automatic air starting valve. Okay, and इसके बीच में आपका वो जो जैसे हमने पहले देखा था कि उसका वो आपका जो क्या बोलते हैं स्लो टर्निंग मेथड है वो सब भी होगा, वो मैंने दिखाया नहीं है. ठीक है, I've just shown the automatic opening of the auto start valve. And then you got the main 30 bar line. The main 30 bar line is also getting your signal to a starting and distributor. Your main line is also going over here to starting and distributor over here. And then from starting and distributor, when the position is going to be satisfied, it is going to give the pilot air. And then main line 30 bar is also coming to your air starting. That is right. So let's just go over this system before actually seeing the actual simulator. Okay. So as you see here, we have got 3 positions: one stop, stop and run. Okay. So ये तीनों actually micro switches हैं. Okay. Nowadays there is a separate thing. You do not have these mechanical micro switches. You've got electronic what do you call levers and electronic sensors and everything. ठीक है, तो micro switch वाला system इतना आजकल common नहीं है. ठीक है, you have got it being replaced by everything, but just for understanding we'll understand this. Okay, then we'll see the actual simulator. इसके अंदर क्या क्या है वो देखेंगे. तो idea क्या है? You've got one start button, one stop button, one run button. Okay, so as I said, stop is instantaneous, start and run is start is again instantaneous and run is a variable. Okay. So stop signal, as long as the stop signal is being pressed, so suppose ये ऐसा जाकर के stop micro switch दबा हुआ, the stop signal is basically going giving a stop signal on top of your puncture valves, not allowing your stop signal to go ahead. ठीक है, हमने वो भी देखा था कि stop condition में आपका जो automatic air starting valve है वो भी depressurized रहता है और आपका starting air distributor भी depressurized रहता है. तो वो तो आगे का बात है, but this is just we are talking about this system. So basically here you got the 7 bar control air. 7 bar control air is giving here and going on top of the puncture valves, not allowing the admitting of the fuel pump to be allowing the air admission. Fuel admission. Then you have got the start signal you have got here. Okay, so start signal and you have got the run signal. Okay. So as soon as you are trying to move this switch ahead, okay, इसको कर देते हो. As soon as you start moving the starting handle ahead, suppose you move it in this direction, the stop signal is no longer satisfied, and now the start signal is going to be satisfied. The stop signal basically slip away, and now stop signal will no longer go, and start signal still start going. Okay. So it allows the passage of the control air through a series of interlocks. Okay. That means if no interlock is blocking it, okay, if no interlock is activated, then it will allow the further transmission of the air to this second interlock, final interlock way. ठीक है, मतलब initially ये interlock से निकल जाएगा, आगे जाके यहाँ पे रुक जाएगा. ठीक है. Now if the reversing is completed, so suppose अगर आपका head या astern जो भी situation था, that has been completed. So suppose I am in the astern situation I stopped. Now I want to go in ahead situation. So what I do, the 7-bar control air is coming here, I go into the ahead switch, I press this here. Now the 7-bar is basically depressing this astern switch को lift हो जाएगा. So astern signal will no longer go. Now the ahead signal is going. Ahead signal will go and push this reversing cylinder back. Okay, changing the roller point of contact, making it from astern to ahead. At the same time, one signal is going to the starting air distributor servo cylinder, horizontal shifting of the starting air distributor cam position, and that will basically go from the astern cam to the ahead position. As soon as that happens, this is going to move ahead, sorry, it's going to move behind in this case, okay, sorry, ahead in this case, and at that time, what is going to happen is air which is going to go out, okay, which is basically the astern signal which is being satisfied, okay, वो जाके ये माइक्रो स्विच के थ्रू निकलेगा in this case, ठीक है, तो ये माइक्रो स्विच के लिए निकलेगा, and this block wall will ensure that only ahead or astern signal is going to be achieved at one time, okay, and now it is going to give that signal going through this, and a second signal, what you call interlock, which is your reversing complete interlock will be satisfied, so reversing is completed, and now the air is going to the starting air distributor for ready for air distribution, okay, and then when that happens, the 7-bar control air sir is making your starting air distributor being depressed, okay, and now that it is basically turning the starting air distributor spring is being compressed for, okay, and now ready to operate below, basically idea was, and then your signal is going to open your automatic air starting oil, जो यहाँ पे explain नहीं किया कैसे काम करता है, एक खोल दिया और फिर आपका starting air distributor पे आपका main 30 बार जा रहा है, and that is basically going to give the position to the starting signal, और फिर यहाँ से pilot signal जाएगा आपको main starting wall में, और फिर वो आपका यहाँ से side से आपका जो main air आ रहा है उससे करके आपको engine को घुमा दे, ठीक है. So basically now your signal, your air is starting to turn, and now your 30-bar pilot air is entered into this thing, and it will start the engine operating. Now when the engine starts operating at that particular time, you will want to go into the run position. So that means the starting handle will be moved further ahead. Okay. As soon as you start to move this signal further ahead, okay, after a particular RPM, okay, the air running will be cut off, okay, and now the fuel running will start by putting the run signal, and now the run signal will allow the governor to control as per the run handle. It will give the linkage to the fuel linkage, and it will basically control the supply of the air to the governor, and it will adjust the linkage as required, okay. So varying signal will be going to the governor, okay, and now this control air will basically fed to the governor to increase the fuel proportion as required, okay, and that is the idea for the entire system. Now you want to stop the signal, so you again go to the stop control. As soon as it goes, the run signal will be not satisfied, stop signal is satisfied, it will go and puncture wall कर देगा, और साथ में आपका ये पूरा ये जो आपका जो ये वाला है ये वाला बंद हो जाएगा, automatic air starting valve will close, okay, and your distributor will not get any air, and nothing will be going up here, okay, the entire thing will be removed of any air. So that is the idea of your this thing. So now suppose I want to reverse, okay, now again I want to go into the astern position. Now I want to go into the astern position, and now you wanted to move from the head to astern. So now you will do the astern side, and now you again get the astern signal dotted line. It will go and push this onto the other side, and it will move the roller point of contact. The astern signal will also go to your starting air distributor and move the starting air distributor inwards, okay, or the shift the roller point of contact inwards, okay, and it will basically move the astern signal. Now as soon as the astern signal is satisfied, it will give the feedback from this micro switch, and this will give the the reversing completed interlock to the block wall, and basically now the one side will go and complete this interlock, and then again the automatic air starting valve will be opened, and now the engine can start in the astern mode, okay, depending on which position your engine is stopped, okay, that is the idea, okay. Is this understood?
Yes, sir. Sir, there's a thumb rule for the minimum RPM required before you can admit fuel into the cylinder, right, sir?
Yes, thumb rule नहीं है, RPM हर एक engine का different रहता है, 40%, 30% RPM ऐसा कुछ रहता है.
किसी से तो मैंने सुना था कि it is about 16%, मतलब एक general thumb rule kind of a thing, कि 16% RPM रहता है normally.
I have not heard this. I have heard that हर engine का separate रहता है, ठीक है, like there will be a particular RPM for the ending of the air gun. ठीक है. 16% I am not so sure. Yeah, I will have to check that. Whether 16%. ये कहाँ से आपको मिला some online?
ये सर आई रिमेम्बर एक्चुअली एक सिमुलेटर कोर्स किया था कंपनी का.
हाँ.
तो उसमें जो इंस्ट्रक्टर थे उन्होंने बताया था
16% और MCR
ऑफ जो रेटेड आरपीएम है आपका इंजन का उसका 16% पे यू विल स्टार्ट स्पेशली व्हेन यू आर डूइंग इट फ्रॉम द मैन्यूवरिंग प्लेटफॉर्म इमरजेंसी मैन्यूवरिंग कर रहे.
क्रैश मैन्यूवरिंग के ऐसा कुछ है ना. क्रैश
नहीं क्रैश नहीं सर. वो व्हेन यू आर डूइंग लोकली ऑपरेटिंग द इंजन ना, जब आप नीचे मैन्यूवरिंग प्लेटफॉर्म से ऑपरेट करते हैं योर एमसी इंजन, तो उस टाइम पे इनिशियली यू विल एडमिट एयर राइट एंड देन यू विल स्टार्ट टू गिव फ्यूल. So you'll wait until 16% of the RPM has been reached and then you'll start to admit fuel. ऐसा उन्होंने बताया था. 16 था या 12 था, I cannot remember exactly. But ऐसे एक thumb rule बताया था.
I have to check this. Thumb rule ऐसा देखो, ऐसा जो चीज है ना, I haven't come across somewhere written. ठीक है. If I find a written this thing, then I will share it with you guys because ये हाँ वो अगर कोई किसी के explanation से है by the experience, he is telling that is a different idea. ठीक है. But as far as I understand, I have not come across some idea like this.